Coming at you live from Channel 24, the world has shut down. The novel UT virus has run rampant across the globe and is now considered a pandemic. Health officials have stated countries need to go into lockdown and people should voluntarily self-isolate. Scientists are still unable to determine the surface structure of the protein, but they have identified it as a spike protein like the COVID-19 virus. Much is still unknown about the protein, but we have hope knowing scientists are pursuing a vaccine. The World Health Organization predicts that if all goes well, vaccine production should begin by the end of the year. Stay tuned to Channel 24 News for new information about the UT virus.
The scientists at the frontier of biochemistry, Rahul and Zach, are working hard at trying to identify the protein in UT virus. They have two vials, one with the COVID-19 protein and one with the UT virus protein. Both are marked with their molecular weights. Rob plans to use these vials to begin determining the protein sequence of the new virus. Oh no, Zach accidentally spills both vials onto the table to create an unknown mixture. Rahul quickly scoops up the mixture back into the vial. They're stumped. How are they going to separate the two proteins? Zach quickly realizes that the one solution they have left is using SDS page to separate the two proteins. But how can we separate the UT virus protein and the COVID-19 virus protein when we only know their molecular weights?
SDS page is a separation technique that uses gel electrophoresis to move charged protein molecules through a matrix and separate them based on size. Before running the proteins through the gel, they have to be given a negative charge. A detergent, SDS, is applied to the proteins and causes them to unfold and gain a negative charge. Uniform coating leads to a consistent charge-mass ratio between all the proteins. Since the proteins are now prepared, they're run through a gel matrix that has an electric field running through it. Electric fields apply a force on charged molecules, and the force applied can be seen through this equation, F equals QE. Negatively charged molecules experience a force opposite to the direction of the electric field lines. What this means is that the negatively charged molecules will move towards the positively charged electrode and away from the negatively charged electrode. The gel exerts a retarding force, or a frictional force, that increases with increasing molecular size, so that each molecule's velocity is set depending on its size and charge. When the electric field is turned off, the smaller molecules will have traveled farther than the larger ones, and thus a separation by size, or molecular weight, is complete.
Rahul quickly inserts the mixture into the gel and connects it to an energy source that provides the uniform electric field. The loaded sample begins to move through the gel and everything seems great, but suddenly Zach notices that the samples are moving in the wrong direction and are almost falling out of the gel. He quickly turns out the machine and realizes that the positive and negative electrodes were in the opposite locations. After salvaging what they can from the experiment, Rahul and Zach repeat the experiment and successfully isolate the UT virus from the mixture. A few weeks later, they use the same isolated protein to determine the crystal structure of the UT virus, which ends up playing a huge role in vaccine production later in the year. Rahul and Zach then win the Nobel Prize, all thanks to their knowledge of SDS page.